This content is produced by PassTheCSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable, source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. An empty dirt lot is not actually empty. It is crossed by invisible limits above ground and buried facilities below ground. Property lines, setbacks, benchmark elevations, finished floor elevations, utility paths, and drainage grades may not be obvious to the eye, but every one of them can control what happens next. The central idea I want you to carry through this lesson is simple. A general building contractor protects and builds from survey control. A licensed land surveyor, or an authorized registered civil engineer acting within that authority, establishes legal boundary control. I call that control versus creation. I can read the control, transfer it, preserve it, and use it to build. I do not create a legal property line or casually replace a destroyed property corner. That distinction sounds small until a crew is standing beside a missing stake, a trench is already open, and somebody says, "Just put it back where it was." That is exactly when a contractor has to slow the job down enough to protect the job. Survey control is valuable because construction depends on repeatable reference points. A benchmark gives the project a stable elevation reference. Grade stakes communicate where planned grades or elevations must land. A property corner or boundary monument carries legal meaning. Finished floor elevation tells the crew where the completed floor is intended to sit relative to the project control. These items are connected, but they are not interchangeable. A benchmark is not automatically a property corner. A fence is not automatically a property line. A wooden stake that says finished floor is not permission to move a legal monument. The contractor has to know what kind of control is present before touching it. I put the responsibilities side by side because this is the cleanest way to remember the boundary. The survey professional establishes or reestablishes legal property lines, sets and tags boundary monuments, and performs the professional work needed to reference threatened monuments. The general building contractor reads benchmarks and stakes, protects the control, transfers layout to working lines, and builds to the approved elevations and setbacks. The practical memory connection is this. The survey professional creates legal control. The contractor protects and uses that control. When the line between those roles is respected, layout stays useful and legal responsibility stays clear. Suppose a crew finds an old iron pipe near a corner of the lot. One worker thinks it is scrap. Another thinks it is the property corner. The correct contractor decision is not to choose the more confident worker. The decision is to protect the object, check the plans and survey information, and coordinate with the proper survey professional before disturbing it. A benchmark matters only if the crew can return to it and get the same answer. That means the reference has to remain stable, identifiable, and protected from grading, demolition, traffic, and material storage. A benchmark that gets buried under spoils or knocked loose by equipment is no longer reliable control. The same principle applies to grade stakes. The contractor does not need to treat every temporary stake like a permanent monument, but the contractor does need a plan for preserving the information before excavation removes the stake. That may mean documenting the stake, transferring its elevation, or coordinating replacement through the surveyor when the control is outside the contractor's authority. Finished floor elevation is one of the most useful ways to understand the chain. The benchmark is the stable reference. The survey or approved layout relates the finished floor elevation to that reference. The contractor then carries that elevation through excavation, forms, foundation work, framing, and site grading. A missed transfer early can keep showing up later because every following operation builds from the same starting elevation. The reference table on screen separates the common site controls by function. A benchmark controls elevation. A grade stake communicates a planned grade or elevation. A property corner or monument controls a legal boundary information. Finished floor elevation controls the intended height of the completed floor. Batter boards and string lines preserve working layout outside the excavation area. The chart is not a substitute for the plans or the survey. It is a reminder that each item answers a different question. When a crew asks, "What does this stake mean?" the answer has to come from the marking, the project documents, and the person authorized to establish that control, not from guesswork. A good field habit is to protect the original control and create separate working control. That keeps the crew from repeatedly occupying the one point that cannot be replaced casually. It also makes it easier to verify work as the job moves from rough grading to forms and then to finished elevations. Survey monuments deserve a higher level of caution because they can be part of the legal record of property boundaries or subdivisions. When construction threatens to disturb an existing monument, California law requires the monument to be located and referenced by a licensed land surveyor or authorized civil engineer before the disturbance. That means grading, paving, trenching, sidewalk replacement, and demolition can all create a monument issue before the operator ever realizes it. A small brass disc in concrete, an iron pipe at a corner, or another durable marker may look ordinary to somebody focused only on production. The contractor has to recognize that destroying it can erase evidence that other people rely on. Imagine a contractor replacing a driveway and adjacent sidewalk. A machine operator reaches a small brass disc that lies directly in the demolition path. The safe supervision decision is to stop that immediate work, protect the area, and coordinate the required survey reference before removal. The contractor should not photograph the disc, measure from a fence, remove it, and assume those notes are enough to recreate a legal monument later. After a boundary monument is set, reset, or referenced, the licensed survey professional has the filing responsibility for the corner record within 90 days. That filing is not a task the general building contractor performs. The contractor's responsibility is coordination and protection, especially before the point of disturbance. The simplest way to avoid a costly mistake is to include survey control in the pre-construction conversation. Ask what monuments are on or near the work. Ask which marks are temporary and which carry legal significance. Ask what will be destroyed by excavation. Then place physical protection around important control and tell the equipment operators what cannot be touched. The same control mindset applies below ground. Before excavation, the proposed area has to be made visible for the underground service alert process. California requires the planned excavation area to be pre-marked in white. White paint, white stakes, white flags, white chalk, or baking flour can identify the intended dig area. The color matters because the white marks communicate the contractor's proposed excavation. The utility owner or locator then uses the established utility colors for the facilities. Mixing those roles creates confusion before the first bucket enters the soil. After pre-marking, the contractor contacts the regional notification center at least 2 working days, but not more than 14 calendar days before excavation. The day of notification does not count as one of the working days. Weekends and state holidays do not count as working days. Here is the common scheduling trap. Imagine the request is made on Friday before a Monday state holiday. Friday does not count. Saturday and Sunday do not count. Monday does not count. Tuesday is the first working day. Wednesday is the second. The earliest excavation day is Thursday. I put the sequence in one table because every step depends on the step before it. First, pre-mark the proposed excavation in white. Next, contact the notification center inside the allowed notice window. Then wait through the required working days before excavation. Preserve the field markings. When a marked facility crosses the work, respect the tolerance zone and expose the facility before using power-driven excavation near it. If the work continues beyond the active ticket period, renew the ticket. A California ticket remains active for 28 calendar days from issuance. That does not mean every mark stays perfectly visible for 28 days. The contractor still has to preserve the markings and renew the ticket when excavation continues beyond the active period. The tolerance zone is another place where people hear the number but picture it incorrectly. It is 24 inches on each side of the field marking, not 24 inches total. I think of it as a protective halo around the marked facility. Inside that halo, the contractor must determine the exact location of the subsurface facility using hand tools before using power-driven excavation or boring equipment. The painted line is an approximate surface indication. It is not a guarantee of exact horizontal position or depth. Suppose an operator keeps a bucket 18 inches away from a yellow gas mark and believes that distance is enough. It is not enough because 18 inches is still inside the 24-inch zone on that side. The contractor has to expose and verify the facility first. The immediate consequence of skipping that step is that the machine is working where the law expects careful exposure, and the possible consequences include a damaged facility, service interruption, emergency response, injury, delay, and financial liability. The memory connection is straightforward. White shows where I plan to dig. Utility colors show what may already be there. 24 inches on each side is the protected zone. Hand exposure comes before powered excavation in that zone. Once legal and utility control is protected, the contractor still has to transfer the building layout into a form that can survive excavation. That is where batter boards and string lines become useful. Survey points may sit close to the exact area where footings and trenches will be excavated. If the crew relies only on stakes inside the footprint, the first grading pass can destroy the layout. Batter boards are placed outside the excavation area so the working lines can be removed and restored while the ground inside the footprint is disturbed. Taut strings between opposing batter boards represent building lines. Their intersections represent corners in plan. A plumb bob can transfer an intersection down to the ground or into the excavation. The contractor can then check distances, diagonals, and alignment without asking the excavator to preserve a stake in the middle of the trench. The 3-4-5 method is a field application of right triangle geometry. Measure 3 feet along one line, 4 feet along the perpendicular line, and check the distance between those two marks. When that diagonal is 5 feet, the corner is square. Larger multiples can improve the usefulness of the check on a larger layout, but the same proportion remains. The method confirms a right angle. It does not establish the legal location of the building. A perfectly square foundation can still be perfectly wrong if it was squared from the wrong control. That is why geometry comes after verified survey control, not instead of it. A practical supervision sequence is to verify the controlling points, establish batter boards outside the work, pull the building lines, check dimensions and diagonals, confirm the intended setbacks and elevations against the project documents, and protect the setup from equipment and material traffic. Each check answers a different question. Square answers geometry. Setbacks answer location. Benchmark and finish floor elevation answer height. Elevation control continues into drainage. The completed site cannot merely look smooth. It has to carry surface water away from the foundation. For residential grading, the ground beside the foundation must fall at least 6 inches within the first 10 feet. That is the soil condition people most often remember. Impervious surfaces within 10 feet of the foundation, such as concrete flatwork, must slope at least 2% away from the building. The comparison table shows why the numbers are different. Pervious soil absorbs water and needs the steeper fall of 6 inches over 10 feet. Impervious concrete or asphalt sheds water more readily, so the minimum is a 2% slope away from the building. Where a physical barrier prevents the full soil run, the project still needs an approved drainage method, such as drains or swales, that carries water away. The important distinction is not that one material deserves more attention. It is that water behaves differently on an absorbing surface than on a smooth, non-absorbing surface. If soil is nearly flat beside a foundation, water has more time to soak in near the footing. If concrete pitches back toward the building, it collects and delivers runoff to the wall. In both cases, the field decision is to verify the direction and the amount of fall before the work is accepted or concealed by later landscaping. California sites can include expansive soils that change volume as moisture changes. Surface drainage does not solve every soil or foundation issue, but poor drainage can add moisture where the structure least needs it. That is why grading control belongs in the same mental category as benchmark control. Both are elevation decisions, and both can affect work long after the stake or string line is gone. On a tight lot, do not invent a reduced slope because there is less room. The source-backed rule recognizes that physical barriers may prevent the full 10-foot soil run, but the solution is drainage away from the building through an approved method, not a casual compromise that leaves water trapped at the foundation. Excavation also brings a separate safety responsibility. California occupational safety rules require a competent person for excavation inspections and for the oversight connected to structural ramps used for equipment access or egress. A competent person is not simply the most experienced person standing nearby. The person must be able to identify existing and predictable hazards, and the employer must give that person authority to take prompt corrective measures. Knowledge without authority is not enough. Authority without the ability to recognize the hazard is not enough. This matters during survey and layout coordination because control points often sit close to changing excavation conditions. A crew may be focused on saving a string line while a ramp, changing surface condition, or underground conflict creates a more immediate hazard. The competent person has to be able to stop the operation and correct the condition. The contractor's best coordination happens before production pressure takes over. Confirm the surveyor's control, identify monuments that need protection, pre-mark the excavation in white, complete the notification process, designate the competent person, establish working layout outside the dig area, verify finished floor and drainage elevations, then brief the operators and foremen on the control that cannot be disturbed. I want to close the technical part with one field checklist you can remember without carrying a textbook. First, identify what each mark controls. Is it elevation, working layout, utility location, or a legal boundary monument? Second, protect original control before equipment enters the area. Transfer information to working control only within the contractor's role. Third, never guess at a property line or reset a boundary monument. Bring in the licensed survey professional when legal control is uncertain or threatened. Fourth, pre-mark excavation in white. Give the required notice. Preserve the utility marks and hand expose within 24 inches on each side before powered excavation. Fifth, keep layout geometry separate from legal location. The 3-4-5 method can make a corner square, but only verified control can put that square corner in the correct place. 6. Carry elevation control through finished floor and final drainage. Soil falls 6 inches in 10 feet. Impervious surfaces fall at least 2% away. 7th, make sure the competent person has both hazard knowledge and real authority to correct the work. That is the connected web I want you to remember. Survey control tells the project where it belongs. Layout transfers that information into the work. Utility control protects what is already underground. Drainage control sends water where it should go. Safety authority gives somebody the power to stop the operation when conditions no longer match the plan. There is an audio practice quiz for this specific episode, and I made it for the way contractors actually study. The questions are read aloud, and you answer by tapping, so it works for people studying while driving, working, or moving through the day. Go to the description below this video. You will see a link that says PassTheCSLB. Tap it. It will take you straight there. Comment below with any questions about benchmarks, stakes, elevations, monuments, utility marks, drainage, or protecting survey control. I read those questions because they show me where the material needs a clearer explanation. Subscribe so you can stay on track through every episode until you get your license. I want this process to feel manageable, one focused lesson at a time.